Hello, hello, hello. This is Ratios and Rates, lesson number 9. This is like the last part of the topic, distance time graphs. And yeah, we'll see what you think of them. And they're graphical. First time this entire unit where we're really looking at graphs rather than just doing calculations. So you get a lot of real life situations this way. So distance times graphs, distance time graphs, that's page 33 of your booklet. Distance and time. Time is the independent variable. So it's the variable that determines your position. So it's written on the horizontal. Distance depends on time. So it's on the vertical. That's something from science. Dependent on the horizontal. Independent on the horizontal. Dependent on the vertical. Object moves at a constant speed. Then the graph, when it moves at a constant speed, the graph will be a straight line. Whoa, 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 whoa. I remember that problem. Yeah. There we go. So graph's moving at a constant speed. So the graph below, here it's moving at a constant speed up. There it's moving at a constant speed. There it's moving at a constant speed. Distance versus time. Whereas in green, in between those two, stationary, stationary, stationary. Flat bit means no movement, stationary. And that's with an A at the end, not an E. Stationary with an E is pens and pencils. Steepness, so this is constant speed. We get right into the examples. So I'm going to scroll down a little bit in 3, 2, 1. Example 1. Distance time graph. So it shows distance from home. That's important. So it says distance from home. So you start at home and then starts moving away. Starts moving away, stops for a little bit, go on. So find Noah's speed in the first hour of the journey. What we need is this thing from last lesson. Triangle, alphabetical order, distance, speed, time. Speed is distance over time. First hour of the journey, so the time's definitely 1 hour on the bottom. How far does Noah go in 1 hour? 6 a.m. to 7 a.m. That looks like 25 kilometers. So it's in between the 20 and the 30. So 25 kilometers per hour. How many minutes was Noah's first rest break? So that's that little break there. Now each square is half an hour. 7, so like that's 7. And that's 7:30 and that's 8 a.m. So that's half of half an hour. So that's 15 minutes. Half a square is 15 minutes. Find Noah's speed between 7:15 and 8:30. So 7:15, that's when the break ends. And 8:30, where is 8:30? 8:30 is there. So from there to there, speed, again, what's our formula? Speed is distance over time. How far does Noah travel? From 25 to 45. That is a total of 20 kilometers. Time taken from 7:15 to 8:15 is 1 hour and 15 minutes. So 1.25 hours. 1.25 hours. Or you could write that, I'll just do it up here. You could have done that as like 1 hour and 15 min. That's 1 hour and 15 over 60 hours. 1/4. Those are all good. So, calculator, 20 divided by 1.25. So this is 20 divided by like, not the right one. No, I'll do it the same way. 20 over, and then that button 1 1/4. Gets a little bit tricky. So 20 over 5 over 4, 80 divided by 5, 16. There we go. I've decided I will have a go at doing calculations, but I won't. I'll say what I'm thinking, because otherwise it's too boring just watching me think. Now, that way, some people can make mistakes with the double fraction. So, safer, 20 divided by just one fraction only. 20 divided by 1 and 1/4. That's safer. At what time did Noah start and finish his second break? So, break started here. That's halfway between 8 and 9. That's 8:30. Finishes at 9:30, 9:30, 9:15. So it's start at 8:30. Yep. a.m. Finish 9:15 a.m. Approximately what time had Noah ridden 65 kilometers? Now this is tricky. So 65 kilometers, you look at the graph, it's never got up to 65. Never got up to 65. So we have to go, he went forwards and then went back. So in total, you can see he went 45 Ks forward. So then, how long did it take him to go an extra 20 Ks? So 65 it's that first 45 kilometers plus another 20. So Noah did 25, did another 20, 45. Now 20 Ks back, 45 minus 20 is there. That. And that's at 10 a.m. At approximately time 10 a.m. Noah had done 65 Ks. I'm impressed. 65 Ks. And we got F and G. Noah's speed on the return journey. So just on the return journey, go this light blue here. Speed equals distance over time. Distance is the times down here. Sorry, first point there. Starting point, finishing point. Distance, top to bottom, did the whole 45 Ks. Time, how long did Noah take to do those 45 Ks? So what is 9? It was 9. Starts at 9:15 a.m. to 11 a.m. That's 1 hour and 45 minutes, which is 1 and 45 over 60 hours, which is 1 3/4. So 45 over 1 and 3/4 hours. Calculator. And I'm going to do it the divide way. 45 divided by shift fraction button. 1 3/4. And that's in the fraction form. So I'm going to press that button. 25 point, we'll call that 7 kilometers per hour. Oh yeah, it's set to 1 decimal place, so definitely 25.7. Average speed for the whole journey. So again, green, speed equals distance over time. That's our fourth speed calculation. Total distance, 45 Ks one way, 45 Ks back. So that's 45 plus 45, which is equal to, not 45 plus 4, 45 plus 45, 90 kilometers. Time taken. Started at 6, finished at 11. Five hours. 90 divided by 5, 16 kilometers per hour. Whoa, a lot going on there. The number one skill is reading graphs. Understanding every single point. So if I just pick some point there, what we have right here, that is 6 a.m. and it's 0 kilometers. And then you pick another point, 11 a.m., 0 kilometers. And up at here, we have at 9 a.m. up there, right there, 9 a.m., 45 k's. You need to be able to read points. All right, got to scroll down. 3, 2, 1. All right, now these are a bunch of questions. How many of these am I going to do for you? Whoa, heaps of them. Maybe I do first one to get you started, and then you're going to have a go at the rest. So graph shows us train journey from town A to town B. How far did the train travel? Well, it went from down here at 0, and then up to there, 240, so 240 kilometers. How long did it take? That's 0 to 3. So 0 to 3, 3 hours. So speed equals distance over time. I'm going to draw a little triangle. Distance, speed, time. So speed is distance on time. 240 on 3. 240 kilometers, 3 hours, 80. That's how you do it. Zoom in a little bit. Yeah. You got to be able to see that. All right, I'm going to pause here. And when you unpause, there'll be a bunch of answers for question 3. There are your answers. Some of them a bit confusing because of the double ups. We have 2 S's, 2 T's. I'm going to scroll down. 3, 2, 1. All right, so have a go at 4 and 5. When you unpause, there'll be answers. Let me get that down. 4 and 5. Pausing. 2, 1. Well, here's the answer just for 4, actually. There's a lot going on there. So, in red, showed where they stopped. Then, showing where they're moving away from home in the brown. Then, the dark blue, when they're towards home. And then I put on afterwards speed. We had the fast bits. I haven't talked about this. Steep bits are fast, where it's steep that way or steep that way. It's moving quickly. A lot of distance is being traveled in a short amount of time. But when you're moving like this, not much distance being traveled in a long time. All right, that's 4. Now, when you unpause, there'll be answer to 5. 3, 2, 1. And there are your answers. For E was a bit tough because it wasn't exactly at the 3-minute mark. It was between 160 and 200, but it wasn't exactly halfway. So I said about 175. That's going to happen. All right, scrolling down. 3, 2, 1. And number 9, last one. You got to draw a distance time graph. Draw a graph and then calculate the speed. So I'll help you get started on the drawing. It's a big graph. We got it. So train travels 5 kilometers. I'm looking at time's going to be on the bottom. And you always start at 0. Well, okay. Now it's 8 minutes, then 2 minutes. So I'm just going to do 8, 2 minutes, another 10, another 2, another 15. So total 10, 20, 22, 37. We need at least 40 minutes. How many squares we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we got 20. So 40 divided by 20, we can do every 2 minutes. So that'll be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 24, 28, 32, 36, 40. I didn't write 0, 2, 4, 6, 8 just because then there's too many numbers. Okay, now distance, pink, 5 kilometers. Stops, then 12 kilometers. Stops, 10 kilometers. 17, 27. So we only need to go 30 Ks. It's not very far. And it looks, I'm assuming it's 20 here as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 squares as well. So we got 20 squares here, and we're only going 40, how many Ks? 27. But we'll still do the same thing. We'll still do every 2 Ks. So 2. I'll use the same color. No, I won't. 4, 8, 12. So this takes time. Oh, that's not 14. Started to talk. This takes time, setting everything up. Totally necessary, though. Totally necessary. And 2. Now you've got everything in place. Oh, time. So this is distance. Well, just distance. I was going to say distance. I'm going to say from the starting point. Just to make that clear. And in kilometers. So in brackets, I put the units. In the time, I failed to put down minutes. Very important, time in minutes. Okay, now you've got that. So your job is to plot the graph now. And, oh, should have a title. This is train journey. Distance versus time. I was going to say distance versus time. Let's go. Train journey. Cool. All right, pausing. When you unpause, you'll have a graph. I got here just the points. Because after you've got the points, all you can do is line them up, join them up with a ruler. In green, I just did the working out. 8 plus 2 is 10, plus another 10 is 20, plus another 2, 22, plus 15, 37, just to show how far up we'd gone each time, because it was getting a bit hard to keep track of things. Bang, bang, and we're assuming constant speed. Straight line is constant speed. And that's your graph. And then, final thing, scrolling down, 3, 2, 1, calculate the average speed. Speed SDT. I'm going to change color. I just feel like it. Oh, SDT. Jeez. Oops, a daisy. DST. Alphabetical order. Distance equals speed times time. I had speed in my mind. Oh, I did not mean that. Okay, how far did the train travel? We said 37 kilometers. How long did it take to do it? In 37... No, 37 kilometers. That's wrong. Is that... That's 25. I've got that wrong. Look at that. That's wrong. Because... No, 25. Should be halfway in between. There. And then... It should be there, shouldn't it? Okay, I need to check everything. And that's why you draw graphs in pencil. I got that wrong because I had everything on the even. I had things at the 6 kilometers rather than the 5. So that's better now. And I actually drew up that table of values. So now that I've done things properly, speed, distance over time, total distance traveled, 27. Over, that's kilometers in 37 minutes. But we don't really like, that's a weird number. I'd say 22 kilometers. How many hours is that? 37 over 60 hours. So calculate 22 That's how much of an hour we have. So 35.7 kilometers per hour. Not very fast. Finally, we're done. I really need to edit videos when I make mistakes, but that's a skill I will have to learn. All right, pausing. No, not pausing, finishing. Done.